A helicopter is taking off and accelerating upward at a rate of 2 meters per second squared for 5 seconds. We want to find the work done by the lifting force and the work done by gravity. We also want to find the net work done on the helicopter. We will draw a free body diagram to help us solve the problem. First, we have the weight of the object. Since the helicopter is going upward and the weight is in the opposite direction of the displacement, the weight will do negative work on the helicopter. The lifting force will be called F. This force will create positive work because it is in the direction of the displacement. The helicopter ascends at a rate of 2 meters per second squared. First thing we need to do is solve for the magnitude of the force F. This will be accomplished by using Newton's second law equation. We substitute in our variables, rearrange the variables to isolate F, plug in our values, and find F to be 5,900 newtons. Next we need to find the displacement of the helicopter. The helicopter ascended from rest, so we know V0 is equal to 0. We also know how long it was in flight and its initial position. We will need to use a kinematic equation. Here's the equation we will use to define the displacement y. We substitute in our values and find y to be 25 meters. In part A, we want to find the work done by the lifting force F. We will use the work equation, substitute in our values, and find the work of the helicopter blades. In part B, we want to find the work done on the helicopter by gravity. We will use the work equation, substituting in the mass times gravity for our force. Input our values, and find the work done by gravity. It is negative because the force is in the opposite direction of the displacement. Finally, in part C, we want to find the net work done on the helicopter. The net work is equal to the sum of all the work done by the individual forces. Here we have two forces, and since gravity is slowing the helicopter down, we subtract it from the work done by the upward force. We substitute in our values and find the net work done on the helicopter.